So today we are talking about linear functions. The Common Core is F for functions, IF for interpreting functions, and 7A, which basically states graphing linear functions and showing intercepts. All right. Graphing linear functions and showing intercepts. Today's 2:9. Okay. Now, linear means it's got to be straight, right? And then in example 1, there's two ways to do it. One way is just to graph it, all right? I mean, if you're not sure, you just graph it and say, well, I'm not sure if this thing's straight or not, but if I graphed it, I might have an idea, right? So if I took a piece of graph paper, right? Let's see if I can graph this. I've got 0, -1, which is here, right? 2, 2, 4, 5, 1, 2, 3, 4, 5, and I've got 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Looks pretty straight, doesn't it? It does look pretty straight. So I would say that yes, this is linear because it's straight. Okay, do you guys see that? Now, there's another way to do it, and that is we can kind of calculate the slope, and if the slope is the same, right? I mean, if this keeps going up the same rate, it's got to be lined up. Make sense? So I could do it another way. I could say, well, I could do my y's. I'm going to do my y's over my x's. So if I took 2 minus a minus 1, that's a 3 over 2, 1 1/2 or 3/2. If we go 5 minus 2 is 3 over 4 minus 2 is 2, same slope. I can go 8 minus 5, which is 3 over 6 minus 4, which is 2. So it has a continuously same slope. So if it has the same slope, up 3 over 2, up 3 over 2, up 3 over 2, it's got to be a straight line. Does that make sense? Because the rate, the slope doesn't change, okay? How about the second example, right? Is it linear? Well, one way we can do it is let's just do the slopes, okay? 1 minus 0 is 1 over 2 minus a minus 1 is 3. Okay? 3 minus 1 is a 2 over a 5 minus 2 is a 3. Uh-oh, I've got a problem already, don't I? It's a different slope. So if the slope is different, I can say no. But again, if I'm not sure what Mr. Davies is doing, I'm totally lost, then we could always graph it, right? To see if it lines up, right? So worst case was, all right, I don't know what you did, Mr. Davies. I can graph this. I can go -1, 0, 2, 1, 5, 1, 2, 3, 4, 5, 1, 2, 3. Oh, that doesn't look straight, right? 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. These three look like they almost line up, but it doesn't line up there, right? So it's not straight. It is a function, but it's not linear, okay? The slope's faster, though. Okay, example 2. Find the equation of the line and graph it if it has a slope of 2/3 and passing through 1, 1. Okay, so I'm going to give you, let's go 1, 1 is right there. And it's got a slope of 2/3, so up 2 over 3, right? Down 2, back 3, right? Let's go ahead and graph it. Okay, so there's my line. But if I want the equation of this line, I'm not sure if it passes through 0 or not. I do know that part of my answer is this. Y equals a 2/3 x plus something. Is it 0? Looks like it's 0. But what if we have to be exact? Does it really go through 0? How could we find out what it goes through? We could use our y equals mx plus b. You guys have done this. Mr. Barr's class, remember you do use a y equals mx plus b equation. What we need to find is the b, right? We need to find the b. So let's find b. Well, let's plug in 1, 1, an x value of 1, a y value of 1, and let's plug in our 2/3. I'll put a 1 is equal to 2/3 times 1 plus b. Remember doing this last year in algebra? You guys remember doing this? No? You never did this? Okay. So basically, let's solve for b. So I'm going to use my equation, 1, 1, got an x value of 1, a y value of 1, so I put the 1 in for y, 1 in for x, and I've got a 2/3 for m. I'm just going to solve for the b. So 1 equals 2/3 plus b, right, because 1 times 2/3 is 2/3, minus 2/3 minus 2/3, and I get 1/3 as b. 1 minus 2/3 is 1/3. So b is really, it doesn't really go through 0, 0, does it? It goes through 1/3. So my equation should be y equals 2/3 x plus 1/3. Now, is this a function? Is this a function? So let's say it is. Now if you don't write this, it's okay, but I want you to get used to it. The book sometimes will write as f of x. Because it is a function. So you need to get in your brain that f of x and y mean the same thing, okay? F of x and y mean the same thing, and the only difference and the only reason we like to use f of x is because we want to say, yeah, hey, by the way, this line is a function. That's the only reason we say f of x, is to say, well, yes, it is a function. Okay? So if you prefer y, that's okay, but you will see f of x in the book. Okay? All right, now, example 3. Find the intercepts of 2x minus 3y equals 12. All right, so let me go back to my reading. All right, the y-intercept can be found by letting x equal 0, right? So let's find the y-intercept. So my y-intercept, we're going to let x equal 0, so I'll go a 2 times a 0 minus a 3y equals 12. So all I did is put it in 0. That's all I did. Let x equal 0 and solve. That's easy. Negative 3y equals 12, right? Because 0. Divide and I get negative 4, okay? So I have a y-intercept of 0, negative 4. Right? 1, 2, 3, 4. There it is. So let's grab the point, okay? X-intercept, well, go back to my reading, and it said the x-intercept is when you let y equal 0, right? So I'll do the same thing. Let's just go and we're going to let the x-intercept, let's let y equal 0, so we'll go 2x minus 3 times 0 equals 12, right? 0 times anything, 0, right? 2x equals 12, right? Divide by 2, and x is 6. So we have an x-intercept at 6, 0. 1, 2, 3, 4, 5, 6. There it is. All right, let me recap real quick. So if you want an x-intercept, let y equal 0. If you want a y-intercept, let x equal 0. It's that easy. And then just find out what it is. Okay, example 4. We did. Yeah, we did this in chapter. We did. And that's the thing about math. You guys forget it. That's why we teach it over and over and over and over and over again. And hopefully by the time you take that state test, you're going to go, I'm sick of this stuff, but I can do it. Right? Isn't that what we want to do, Kayla?
Yeah.
Exactly. Okay, example 4. Write in slope-intercept form. The slope-intercept form is where you got y equals mx plus b, right? That's slope-intercept form. We go to our notes, slope-intercept form. So really, to get this, we have, little side note, we have to solve for y. So I'm going to take my 2x minus 3y equals 12, and I'm going to have to solve for y. Okay, so I've got a 2x minus 3y equals 12. I want to solve for y. Let's get rid of the 2x. Let's solve for y. So we want to get this all by itself. Let's get rid of the 2x. How do I get rid of the 2x? I heard it. Subtract it, right? So if I go minus 2x minus 2x, gets rid of it, right? So I'll have a negative 3y equals. This is not a 10x. Do not write 10x. Do not write 10x. It's just 12 minus 2x. You can't subtract those. One's an x, one's a number, right? Okay. Divide by negative 3, divide by negative 3, divide by negative 3, right? Because that cancels out the negative 3. So you get y equals a negative 4 plus 2/3 x. Now the only thing I'm going to do is switch it around because, you know, the form is the x before the b, so I'll go y equals 2/3 x minus 4. And Kayla, you're right. We did this. We just did this, didn't we, in geometry, right?
Yep.
Yeah. Okay. Thumbs up.
Yeah.
Okay. Turn the page. Did you get it, Daniela? Okay. All right. Example 5. Y equals 3. Y equals 3. How do you graph that? Straight across. At 3. So we'll go up to 1, 2, 3. Straight across. Okay. Now, because I am the kind of math teacher I am, whether it's a good thing or a bad thing, watch this. Just everybody watch. Okay. What's the Y value right here? What's the Y value here? What's the Y value here? What isn't Y always equal to 3? Hey, it makes sense. Math does make sense. I know some kids, math is dumb. Math is confusing. No, math never is dumb and math is never confusing. Sometimes we're confused, but math is never confusing. Okay, x equals -2. How's that look? Yeah, up and down. At -2, completely right. It's vertical. There it is. Oh, the slope of this one, and the slope of this one is undefined. Totally right. Undefined. And the slope of this one is 0, right? Okay. Example 7. So I gave you a little hint in here that helps. Okay, so a road rises 2,500 feet to 7,000 feet in 10 miles. Okay, so find the average slope of the road. Okay, so graph the elevation gain. So first of all, let's go ahead and put our feet here. Oh, let's see. I got to get all the way to 7,000, don't I? Maybe 1, 2, 3, 4, 5, 6, 7. Okay, how's that? These are in thousands. You okay with that? And these are going to be in miles. So let's just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 miles. Okay? So I'm going to rise from 2,500 from here to 7,000 here. Okay, going up a mountain, right? So far it looks pretty good, right? So our slope of this is always the change in y's over the change in x's. Always. It's always the y's on top. I want to say this several times. Always the y's on top, x's on the bottom. Always y's on top, x's on the bottom. It frustrates me when I give kids a quiz and ask for slope and they do it just the opposite. They do everything right except put the x's on top. No. It's rise, the y's on top. Okay? Now, let's see what we got. So the change. So we're going to go from 7,000 to 2,500. So that's like 7,000 minus my 2,500 over 10, right? You guys agree with over 10? So what is that? 4,500? Hold on, double check. Clear, 7. Yeah. So 4,500 over 10, right? Which is 450 feet in 1 mile. Okay? So that's correct. Okay? So you're going to gain 450 feet every mile. But what if you want to know it in terms of feet, right? Well, you just do, how many feet are there in a mile? Anybody know besides me? 5,280. Nice. Or it's going to be 400, no, it's no. 450 feet in 5,280 feet, right? And then I can divide that. I don't think I can reduce that. 450 divided by, hold on, 5,280, math, fraction. Yeah, the best to reduce is 15 over 176, or as a decimal. Let me divide that, 15 divided by 176, about 0.8, okay? So, easy. All right, let me stop the recording, and we've got lots of time.